Hello, good morning friends. Today we'll see a lecture on periodic convolution. The periodic convolution is also known as circular convolution or cyclic convolution. So the number of convolution required for the circular convolution is equals to the order of period. So here two sequences are given, x1n and x2n, and the periodic convolution or the circular convolution for these two discrete time signal, it is given as x1n convolved with x2n. This is the symbol of periodic convolution. Let me take the pointer option so it will be more clear to you. Normally this symbol is known as convolution sum. So if you have a circle over this symbol, it is known as periodic convolution. And the formula to have a periodic convolution is what? Y of n is equals to summation for m is equals to 0 to n minus 1 x1 of n x2 of n minus m over period n. So this here we are using the circular shifting property, and this sequence will be as same. Now you can interchange the position also. Here also you can take x1 of n minus m, and here also you can take x2 of n. So there is no change in between. Now I have told you that here we are using the circular shifting property, and the response what we will get is determined by zero padding. Zero padding is what? To make a sequence of a same samples we are adding zero. That added zero is known as zero padding. Now the periodic convolution can be done in two methods or two ways. The first is known as matrix method, and second one is known as concentric circle method. So in today's lecture we will see the matrix method. Now to have a matrix method, let's take example. So here two periodic sequences are given, and we have to determine the circular convolution between the two sequences. Now to have a circular convolution, first you should know the circular shifting property. For that, let me take you one property, circular shifting. So I am drawing one circle. So I have taken this circle as, I have converted the circle into the four parts. Why? Because for the given question the capital N is equals to 4, so the order of period is equals to 4. That means what? The number of convolution for this circular convolution is nothing but the order of period, and that order of period is equals to 4. Here we are having the 4 samples also, here also we are having the 4 samples. That's why I have converted the circle into 4 parts. So here I have taken, see, for a matrix we require a matrix of y of n is equals to matrix of x of n, and second will be the matrix of h of n. So when we are using the circular shifting property, the matrix on which we are using the circular shifting property, that matrix size is n by n, and where we are not using the circular shifting property, that size is n into 1. So here we will be having the 4 by 4, for which we are using the circular shifting property, row into column, and here we are having the 4 row into 1 column. So the answer which we will get, that contains 4 row and 1 column. Now here I have applied the circular shifting property to this sequence x of n. So I am considering this is my 0th position, and originally I have taken the sequence as anti-clockwise. So here it will be 1, then here it will be 2, here it will be 3, and here it will be the 4. So I have shown the dark portion, that means it contains x of 0, x of 1, x of 2, x of 3. So this direction is what? Direction I have taken as anti-clockwise. So when I am calculating x of minus n, so to have a x of minus n, I have to rotate the same sequence in anti-clockwise direction. Sorry, here I have taken the anti-clockwise, so I have to rotate in a clockwise direction. So in the clockwise directions, what I am going to have? In the clockwise direction, I have to move the sequence like this. See here, x of minus n. So this is my sequence of x of minus n. Now to have a x of minus n, I have to read the sequence as I have to rotate Okay, so in what form? In x of minus n. So the sequence is what? Here will be having the 1 samples, okay, then here will be having the 2 samples, here will be having 3, and here will be having the 4. So 1 2 3 4, it is like this. But how I am going to read? As it is as 1 4 3 2. I have to write the sequence as this one, reverse. I have to take the position as reverse, but it will be read as 1 4 3 2. Okay, so it will be always it will be always reading in what direction? In the direction of x of n. So I have to just take a reverse, and after taking a reverse means what? Just we need to change the position here also. Here it will remain same because it is varying. Initially this is my 0th position, so I have to write the sequence of 1, then 2, then 3, then 4, but reading in what way? Reading in the same way. So here 1 4 3 2. So this is the sequence of what? This is the sequence of x of n, x of minus n. That means the first sequence is always equals to x of minus n. The second sequence is x of minus n minus 1 for a period of 4, x of minus n plus 2 for a period of 4, and the sequence is x of minus n plus 3. So you can write this like this: x of minus n plus 3 for period of 4. So first we need to calculate x of minus n. So I have calculated x of minus n, and we have to read the sequence in what manner? We have to read the sequence in the manner of x of n. So in the direction of original. So here original direction is what? Original direction is what? So the original direction is anti-clockwise. Okay, and to have x of minus n, we have to take the clockwise direction and read in the anti-clockwise direction. Okay, now again I am going to tell you for x of minus n plus 1. For x of minus n plus 1, so plus 1 is there, so we have to rotate this sequence. We need to rotate this sequence, x of minus n sequence, in anti-clockwise direction. That means in the direction of x of n. So direction of x of n is anti-clockwise. So position of 2, it is shifted here. So here we will be having 2, here will be having 1, here will be having 4, and here will be having 3, and read in the same as the direction of x of n we have. So it becomes 2 1 4 3, as you can see here, 2 1 4 3. Then again we have to shift, so we will be having 3 shifted here, 3 2 1 4. So 3 2 1 4, again we need to shift, so we will be having this 4 here by shifting as 2. So 4 3 2 1, in that way we have to write. Or the next simple version, you write x of 0, x of 1, x of 2, x of 3 as it is. You shift the value of 3 here, then you take x of 0, x of 1, x of 2, then 2 here, then x of 3, x of 0, x of 1, then 1 here, x of 2, x of 3, x of 0. So the value of x of 0 at the first point, position will be having at the last position. That means it is over, and the size of matrix that time will get as n by n. Then you multiply row into column, will be getting the answer, and you have to take as a sequence. So that becomes your output for the given two sequences as a circular convolution. And the position of arrow depends. Before this arrow there is 0 samples, before this arrow there is 0 samples. So the sequence, the arrow will be at this position before we'll have 0 samples. Now we'll see the next example. So here it can be very clear. So as you can see here, capital N is given as 3, capital 2 is given as 2. So the capital N is nothing but LCM of N1 and N2. So the LCM of 2 and 3 is nothing but 6. So we'll be getting order of period is 6. That means number of convolution you require for these two sequences is equals to 6. So we need to make the sequence of x of n contains 6 samples. So here the sequence of x of n having only the 3 samples. So we need to add 3 zeros. So the added 3 zero is known as zero padding. 1 2 3 and will be having 3 added 0 to make a sequence of 6 samples. So this 3 0, it is known as what? This 3 added 0, it is known as 0 padding. Similarly for h of n, we need to take 4 added zeros. So that 4 added zeros is known as 0 padding. So to make the sequence of 6 samples. So after solving this using matrix method, we will get answer like this. So here I have taken the hint as take LCM of n1 and n2, so that I have already told you, and will be getting the answer. So now you see the position of arrow. So before this arrow, by default this is my 0th position. So before the arrow there is 0 samples, and before the arrow there is 0 samples. So the position of arrow will be at 2 and will be having, before the arrow will be having 0th position. So in that way we need to calculate the circular convolution for given sequences. So just you need to remember the what? You need to remember the circular shifting property. First you take the sequence of x of n. Whatever you require, you take the direction as clockwise, you take the direction as anti-clockwise. If you have taken the direction as a clockwise for the original sequence, so for the negative x of minus n or h of minus n, you have to change the direction. So if you are taking the clockwise, you need to take as a anti-clockwise. If you are taken as a clockwise, you need to take as a anti-clockwise, and then you shift. So for a matrix method, you don't require much of this. You don't require much of this. Let me see here. For the matrix method, you don't require the circular shifting property, but when you go for the circular convolution, you require the circular shifting property, because we need to use the circles and we need to rotate the circle by 1 sample, 2 sample or 3 sample. So thank you very much.